Welcome to another video on smart architectural programming. And in today's video, we'll be focusing on another binary tree problem from our from LeetCode's Blind 75 list of problems, and that is the subtree of a binary tree problem. So in this particular problem, you'll notice that the problem is basically tells us that given that we're given two binary trees with a root and a subroot, we need to return to if that subtree is part of the root tree and the same structure and the node values of the subroot basically. So potentially I would recommend you going to view the same tree problem that we did in a previous video, because that would help you understand the equivalence aspect of this problem in more clarity, right? And there's just a extension of that problem to a degree. So just to give a quick reminder, tree is equivalent if that tree's structure, which is how the depth of the tree, right, and the node values, which are these areas, these values, are equivalent to the respective values here, right? So that is an equivalent tree. Its depth and its node values must be the same. So given that premise, we need to understand in this particular problem is that we need to identify whether a given subroot, which is this particular tree here, can be part of the root tree, which is this one over here, right? So given a subroot, we need to see if we can fit a subroot tree within the root tree. So the best way to go about it, right, again, is using recursion, and we'll get to the base cases or the edge cases of recursion later, but let's basically understand exactly what we need to do here first. So first, basically, we know there's a value 2, right? Let me use a more prominent color that's a little bit different. So we know the value of the subroot's starting node is 2, right? So we need to go over each node on root to see if that is 2 or not. So first we check this here. It doesn't seem like there's a 2 within that, so we cross this out and we move down to this root here, right, and see if this has a value of 2, which it doesn't, right? So we cross this out as well. Then we move to the second side and look at the value here, which seems to be 2. That's what we're looking for, right? So at that point, now we need to compare the structure here, right? This has 2 values going left and right, and it has values of 4 on the left and 5 on the right, right? So we go over here and do the same. That's the case. We have we can say, if these two trees are given to us in our function, we can say, yeah, these values were correct, and we can move forward basically. Given that that's the logic of what we need to do. Now let's see if we can code this problem out, right? But in the code portion, we have two things you'll notice here. We have a helper function and a main function. So let me give you some context to that. So we first do comparison with each node with the root of the subnode, right? If we find the root, then we match the subroot. We need to ensure the subtree is rooted at the node identical to the subroot. That is something that we just explained in the diagram earlier. Moving forward, the solution outline has two aspects to it. It has a helper function, which is the same tree function. This function checks if two trees are identical, which means both have the same trees, the same structure and node values, right? And then we have the main function is subtree. This function traverses the root, checking each node if the subtree located at the node is identical to the subroot. So what is the helper function doing? So let's go back to the diagram here, right? Let's remove all of the mess here. So imagine we have this subroot here, right? This tree, this is the tree we have, right? So the helper function is need to make and would make sure if we come here is that the structure of these two trees with having two branches is the same. That's what the helper function needs to do. And the main function will compare these node values and see if they're the same as well, right? If that makes sense, that should make sense, because that is how we're going to break this problem down and solve this problem, right? So with that in our mind, let's look at our solution here, right? So first you'll notice the helper function, right, is same tree. If both are null, then we return true, right? that is what we're doing. If both are if one of them is null, then we return false, right? If the value is not equal, then we return false, right? And then we do a recursive call on this function, right? Similarly, the main function is like if the root is not the same, we return false. If it is same tree, we return true. And then we recursively check left and right subtrees of root, basically. That's what we're doing in this particular solution, right? So let's run this code. Both of our cases were cleared. Let's submit this code. That was cleared as well. So that is how you solve the subtree of a binary tree blind 75 list problem. If you got any value from this video, please like and subscribe, and let us know in the comments if there's any topic, video, question, or issue regarding programming you want us to create a video on. With that, we're going to wrap this video up, and we'll see you in our next video. Thank you.